Today, let's talk about something truly vital, not just for athletes, but for your whole life and even your longevity. Everything in this video is backed by real science, research, and experts who've spent years studying sleep and the brain. That's muscle. What's amazing about the human brain is how it controls all kinds of movement. Fast or slow, short or long, it's all directed by the nervous system connecting neurons to muscles. We'll dive into how neurons control muscle, touch on some nutrition, and explain a specific amino acid that can help build better muscle. Plus, we'll talk about recovery, because that's when muscle really grows and gets more flexible. Not during exercise, but afterward. Most people think of muscle as just strength. But muscles do so much more. They help you speak, breathe, sit, stand, move, and perform countless skills. Muscle isn't just about the meat itself. What controls muscle is your nervous system. And it does so through three main players. First, there are upper motor neurons in your brain's motor cortex. These handle deliberate movements. They send signals down your spinal cord. In your spinal cord, you have two key groups of neurons. Lower motor neurons send long fibers, axons, to muscles, releasing chemicals called acetylcholine that tell muscles to contract. Then there are central pattern generators, or CPGs. These control rhythmic, reflexive movements like walking, which you don't have to consciously think about. So, muscle control boils down to three things: upper motor neurons for deliberate moves, lower motor neurons that connect to muscles, and CPGs for rhythmic actions. Now, how do you build muscle size and strength? Not always does stronger mean bigger, but often bigger muscles mean stronger muscles. Why get stronger? Because muscles tend to weaken with age. Strength isn't just about lifting heavy weights, it's about maintaining posture, safe movement, and daily function. There's a principle called the Henneman size principle. It means your body recruits motor units, from nerve to muscle, in order of effort. For light tasks, you use small motor units. For heavy tasks, you recruit bigger ones. As you push harder, more motor units get involved. That's when muscles start growing and getting stronger. People often think you need heavy weights to recruit big motor units, but research shows you can use a range from about 30% to 80% of your maximum weight. You don't always need to lift super heavy to build muscle. What really matters is following a few key variables: volume, effort, and fatigue. If you stick with that, you can grow muscle and gain strength. Powerlifters might argue you need heavy weights for maximal strength, but for most people looking to maintain or improve muscle and strength, heavy weights aren't necessary. Three main stimuli help muscles grow stronger and bigger: stress, tension, and damage. Not all have to happen every time, but some kind of stress must be there. Think of this like brain plasticity. The nervous system adapts based on how well you activate muscles. Try this now. Can you contract individual muscles independently? The more you can isolate and challenge muscles, the better your potential for muscle growth. Strength training often involves moving muscles as a system: lifting, pushing, pulling. Hypertrophy training focuses on isolating muscles with intense contractions to stimulate growth signals. To sum up, strength comes from progressively moving heavier loads, while muscle growth comes from isolated, challenging contractions. This topic is one of the most debated in fitness, right up there with nutrition. But science shows that training with weights or resistance bands between 30% and 80% of your 1-rep max is best for muscle growth and strength. If you've done some training before and want to get serious, aim for 5 to 20 sets per week per muscle group. About 5 sets weekly is needed just to maintain muscle. If you skip resistance training, you risk losing muscle size, strength, metabolism slows down, and posture worsens. You don't have to do all sets in one workout. Spreading them through the week works best for recovery. What about movement speed? Moving moderately heavy weights quickly trains your motor neurons for power and explosiveness. Customize your training to your goals. For hypertrophy, focus on isolated contractions and muscle control. For strength and explosiveness, move moderate weights fast. Recovery is key. Rest about 2 minutes between sets for strength and hypertrophy gains. Longer rest can help too, but don't go overboard. How to know if you're recovered? Simple tests like grip strength can tell you how well your nervous system and muscles have bounced back. If your grip strength drops 10 to 20% from your baseline, your nervous system might still be recovering. Another great test is the carbon dioxide tolerance test. It measures how well you can control your breathing and recover. Here's how. Take 4 deep nose breaths. Exhale fully. Then on the 5th breath, inhale deeply and slowly exhale through your mouth as slowly as possible. Time how long it takes. If you exhale very quickly, under 25 seconds, your system may not be fully recovered. Between 30 to 60 seconds is good, and over 60 seconds means you're ready for more work. Tracking this over time helps you know when to train hard or take it easy. Now about recovery tools. Cold therapy like ice baths reduce inflammation and soreness but can interfere with muscle growth by dampening key repair pathways. Also, avoid non-steroidal anti-inflammatory drugs around your workouts. They can blunt gains in strength and endurance. Nutrition plays a big role. One surprising but crucial nutrient for nerve-to-muscle communication and performance is salt. Neurons fire by moving ions, especially sodium, salt, across membranes. Without enough salt, nerve signals to muscles suffer. How much salt you need depends on hydration, caffeine intake, sweating, and other factors. Along with salt, potassium, and magnesium are important for muscle function. Creatine is one of the most studied supplements for muscle performance. About 5 grams a day can boost power output in sprinting, jumping, and lifting by 12 to 20%. Creatine helps cells hold water, reducing fatigue and improving performance. For muscle repair and growth, getting enough of the essential amino acid leucine with each meal is key. Usually 700 to 3,000 milligrams. Most people should get these amino acids from whole foods. Animal proteins like meat, eggs, and fish have a higher density of essential amino acids per calorie than plants. Vegans and vegetarians can still build muscle, but they should pay extra attention to protein quality and essential amino acid intake. Eating 2 to 4 times a day with enough amino acids supports muscle growth and strength well. In conclusion, muscle matters for everything you do, from moving to breathing to living a longer, healthier life. Strength and muscle growth depend on how your nervous system communicates with your muscles. You don't need to lift the heaviest weights, but you do need consistent training in the right intensity and volume range. Recovery, nutrition, and smart supplementation all support this process. Thanks for your time and interest in the science behind muscle and movement.